Alright, so we are on the Mathematics High Level Paper 2 Khomas region for August 2020 exam, and we're on the second last question. Question 13. Yes. Okay, so function f is such that f of x equals that. I'm just going to rewrite that equation. F of x equals 3e to the power x plus 1 for all real numbers of x. Now sketch a graph of f and its inverse on the same system of axes, stating coordinates of the points where the graphs meet the coordinate axes. Okay, so I am going to draw a little graph for us here. System of axes, and let's call them y and x. Fantastic. Alright. So now for this, we see this is an exponential function. So we know it has a horizontal asymptote, and that asymptote is this value here. So at 1, okay, y equals 1, we'll have an asymptote, and let me draw that in for us. So there we have an asymptote at 1. Okay. And then, what else do we need? Well, we need to find the x and the y intercepts. Now in this case, it won't have an x-intercept, it'll just have a y-intercept, because you know it looks like that. So to find the y-intercept, to do that we make x 0, because when x is 0, this line, that is the y-axis. Okay, so if x is 0, we've got y equals 3e to the power 0 plus 1. That gives us 3 times 1 plus 1, so that gives us y equals 4. So right over here, we'll have our y-intercept. Okay, and then we can just draw our curve, and it looks something like that. So here we have at 4. Now for the inverse, the nice thing is we don't have to find the equation of the inverse to be able to draw it if we have the original. Because we know y turns into x and x turns into y, so we can just swap the values. In order to do that, let's maybe just give this proper coordinates, so that's 0 and 4. And this value is 0 and 1. Sorry, that's just y equals 1. Let's call it y equals 1. I'm going to actually do that over here. So y equals 1. Right, so for the inverse, everything just swaps around. So let's do the inverse in a different color. So instead of y equals 1, the asymptote will now be at x equals 1. I wanted to draw that a little bit smaller. X equals 1. Alright, let's just change all this back to what it should be. So here at x equals 1. Right, there we have our asymptote for this one. And instead of 0, 4, we'll have the point 4, 0, like so. And then we can just draw that graph here. Perfect, so there we have it. This is 4, 0. So there we have it. We've got all the asymptotes shown and all the intercepts with the coordinate axes shown. Nicely done. Okay. Give the equation for the inverse. Okay, now we do have to find the equation of the inverse. So let's just write down the original equation again. So f of x was 3e to the power x plus 1. So now to find an inverse, what do? Well, we swap x and y. So instead of y equals, we're going to have x equals, and then the x is going to turn into a y. Now from here, we need to get y by itself. So I'd suggest first minus 1 from both sides. That'll give us x minus 1 equals 3e to the power y. And then I'd probably divide by 3. So we get x minus 1 over 3 equals e to the power y. And then I just take ln on both sides. And why ln and not log? Well, because ln e will give us 1, and that'll sort things out nicely for us. So if we just take ln of the left-hand side, x minus 1 over 3 equals ln e to the power y. Then we know y can move to the front here, so we'll keep the left-hand side as is. X minus 1 over 3 equals y ln e. And ln e is just the same as 1, so that we can just erase. So there we have it. So the inverse is ln of x minus 1 over 3. Now if you didn't choose ln, that would be fine. You didn't have to choose ln, it just makes life a lot easier, and that's probably what the markers expect. But let's say we didn't choose that. Let's say we just chose log with a base 10. So then we'd have log of x minus 1 over 3 equals log of e to the power y. We keep the left-hand side as is, equals, and then y can move to the front as a coefficient of log e. And then we just have to divide both sides by log e. So we'll have log of x minus 1 over 3 divided by log e equals y. So that's also fine. Then we know if we're dividing a log by a log, we can just say this is then the base. So you'd have log base e of x minus 1 over 3, and log base e is just ln. So eventually you would have ln as your final answer anyway. Alright. Function g is such that g of x is x plus 1. Evaluate f of g of 0. Okay, let me just write down f again before I forget that. So f of x equals 3e to the power x plus 1, and g of x is that. So first we want to do g squared. So g squared, just to make sure, it does not mean g times g, right? That is a common mistake. G squared, in this case, if we're taking a function of itself, that means g of g, right? And g of g, so that means we put the whole function g into the place of the x in the other function. So we've got an x plus 1, but what do we place in place of the x? The whole function g. So that's x plus 1, which gives us x plus 2. Perfect. So there we have g squared, and let's do g squared of 0. So that just means we replace the x with a 0, so 0 plus 2 equals 2. And now that we have that, we can put that back into f. So now we can do f of, so this whole thing we found was 2, so we can do f of 2, which is 3e to the power 2 plus 1. And that could be our answer. And let's just work it out in decimals just for the sake of doing that and practicing some rounding off. So we'd have 3e to the power 2, so 3e squared plus 1. 23 point, let's copy this whole thing, copy and paste, and let's round that off to 3 significant figures, so that'll be 23.2, rounded off to 3 significant figures. Good. Now we've got a function j. So j of x equals this, and again we need f, so I'm going to write down f again. So f of x equals 3e to the power x plus 1, and here we have j of x. I'm just going to write that down too. So j of x is e to the negative x plus 3. So now they tell us to solve f of x equals j of x. And they give us a helpful tip here. We can say e of x equals t. So let's rewrite both of these things with a t. So f of x, the nice thing is e to the power x is already part of the equation, so we can just replace e to the power x with a t. Okay, in this one, well, we don't have e to the power x, so how can we get that? Well, we can change this so the exponent sign changes by moving it to the bottom of the line. 1 over e to the x plus 3, and now we can change the e to the x into a t. Okay, so here are our two equations. We want to set them equal to each other. So 3t plus 1 equals 1 over t plus 3. Okay, I'll probably first take the 3 over, so minus 3 on both sides. That'll give us 3t minus 2 equals 1 over t, and then multiply everything by t. So that gives us 3t squared minus 2t equals 1, and then I'll just take the 1 over to the other side, so we'll have 3t squared minus 2t minus 1 equals 0. And again, what a bargain, this one can factorize, so we can have 3t and t, and we'll have minus 1 and plus 1 here equals 0. So then either this equals 0 or this equals 0. So 3t plus 1 equals 0. That gives us 3t equals negative 1, which gives us t equals negative a third. Or t minus 1 equals 0, which gives us t equals 1. Alright, but we're solving for x, not for t, so we have to resubstitute or reverse substitute. So t we know is e to the power x. So e to the power x equals negative a third, or e to the power x equals 1. Now if e is a positive number, right, it's 2.718182, etc. That is the value for t. So it's a positive number, and a positive number raised to any power can never have a negative answer. So this is not applicable. So all we need to work with is this one. So e to the power x, and 1 we can rewrite as e to the power 0. So now the bases are the same, therefore we can say the exponents are also equal. and that will be our final answer. X equals 0. Alright, that's it for question 13, and then the last question, yes, question 14 will come up shortly.